Hello, folks, and welcome back to Advent of Code. This is day number 18. So, there's a couple extra minutes before we get started. So, I wanted to talk a little about mental health stuff that's going on because, it's been a complicated and frustrating and a little bit of up and down couple of days for me, and I kind of wanted to talk a little bit about it. So for me, Advent of Code is really, really important to me because it's kind of a place where I get to feel that kind of dopamine rush of having accomplished something. And it also is a way to kind of connect with being technical, to connect with problem solving, and that can be a little challenging sometimes. In particular, definitely it used to be the case that I was a perfectionist and I used to beat myself up, sometimes metaphorically and sometimes actually engaging in self-harm if I was not perfect, if I made a mistake. And it's challenging to break out of being a perfectionist about things and self-harming if you make a mistake to taking it in stride, let alone taking it in stride publicly. So yesterday was a little rough, but I feel pretty proud that I was able to get through it, and that nothing bad happened. I wasted 35 minutes on a missing set of Boolean operators, but I think it's important to recognize that I've kind of come a long way since I used to self-harm, and I'm pretty proud of that. But as with all things, there is always work to be done, and the particular bugbear that I'm fighting right now has been, even if I can accept being not perfect, I still find it really, really challenging to accept that I am capable of a finite number of things, and as someone who is disabled, as someone who has a autoimmune condition, that means that I am tired all the time, that I can't do everything that I want to. So yeah, it's been a tricky couple of days in terms of realizing that, hey, I cannot just keep on throwing myself at this brick wall and hoping that I will magically surmount the brick wall through force of will. So yeah, I've been a little bit emotionally weird recently because it turns out that going from denial about a problem to going to acceptance, there's emotions involved in that process. There's bargaining, there's coping, there's grieving, and goodness knows that I've gone through a lot of grieving the past couple of days with wait a second, I need to decrease the number of things I'm doing. I need to potentially take more time off of work less, so that I can spend time doing things that I enjoy. But one of the things I was pretty adamant about was I am not stopping doing Advent of Code. That is one of the things that I think I dearly appreciate. I want to keep on doing, and if I have to drop something, it's going to be something else other than that. Good news is I go on vacation. Tomorrow is my last day of work until the new year, so it's going to be good. But yeah, it's doing code like this and having community like you all, that really matters to me. And especially the thing that happened today was I was on a AWS broadcast, and someone was a awful mean-spirited bully who launched a few transphobic attacks against me, and that stung for a second because I've been harassed physically in person by people who are transphobes, and I felt that same sense of fight or flight, danger from that. It's the internet. That person could not hurt me, but still, that was a little scary. And I'm glad to be with you all in this particular community right now, that we've cultivated in the Advent of Code community, because you all are so supportive, and that means a lot to me that I can kind of cultivate and curate that audience. So yeah, that's what's going on, but I'm looking forward to doing this coding puzzle with you all, so let's go ahead and get ready to get started with that, and I'll see you in a couple of seconds. right. All right. Let's swap that around. And let's change this up too. And we are good to go. Okay. Mental health stuff is hard. Health stuff is really hard, but you know, it's important to talk about. All right. Operation Order. Oh, I didn't point out this in previous days. Eric Wastel pointed out to me that all of the puzzle titles are alliterative, which I didn't notice the first time around when I was solving them, but now I do try to read out the title and giggle a little. Okay, our airplane is over a continent. We need to do some math homework, and this follows some different rules. Let me peek at that, but I don't want a copyright strike. Okay, actually, that does contain Disney copyrighted material. I am not going to watch that on stream. That'll get me a copyright lickety split. Okay, addition, multiplication, and parentheses. Operator precedence, they're evaluated left to right no matter what. Okay, so we need to do an AST. Okay, this is straightforward. So we have a bunch of math lines, and we need to parse them. So I fortunately have written a parser for compilers class before, so I know how to do this. So let's just double check this. So get my puzzle input. All right, this ends in 7 plus 7. That's good. All right. So we'll write that out to disk. Over here. So the way that this gets encoded here is a expression can contain and then it can also contain a operand. In fact, I want to not just have in fact, expression needs to be an interface. So how do I do an interface in Golang? Because what I want is I want an expression to have a value statement, and therefore after that we can construct terms. So let's see. How do we do this? So actually this can be, we don't need to construct this as normally. If this were a programming language, I would construct this by using pairs at a time. Because this is just straightforward right to left, or left to right, then we can just construct this as sequence, which has a set of okay, so I think this should do it. All right. So a interface has the value okay, so that should work. Okay. All right, so a sequence evaluation all right, so that starts with the 0th term. And then operators index I-1, operate result, comma, v. Yep, that works. All right, and finally, we need to define what an operator does. So operate returns an int. And now we can just define actually, wait. This can just be okay, that works. And then all right, can this be made a static? Oh, right. That's just literally this. That just literally is the same thing as this. Okay. All right. And the other possible thing that a expression can be is that an expression can be an expression can be a we need to that needs this as well. Okay, now this works. So now we do nested evaluation, all is well there. Okay. What is the sum of the resulting values? All right, reasonable enough. Let me just make sure that this type checks. It does not type check yet, so line 17. All right, line 21. Oh. And okay. this almost type checks. And this just is performing the operation directly like this. Okay, wonderful. We have a basic numerical type system now that now type checks. So let's go ahead and let's parse the lines. So let's look at my input real quick to see what it might look like. So the tokenization is straightforward. We just tokenize by spaces. There will always be a there will not always be a space between them. There could be a paren as well. Okay. So how do I handle tokenizing this? I really wish that there were literally a space. You know what? I can just munge this. That's fine. So if I see two parens together, if I see two parens together, so we're just going to do this really quick. Are there any triple parens? No. Okay, there are no triple parens, so that makes my life easier. I'm just going to replace... by the way, if you love this, the Indelible Ink, there is Afer's coding interview, hexing the technical interview, typing the technical interview, etc. These are so good. Eric... No, Eric. No, bad Eric. Let's see. So anyways, Afer's Xing the technical interview is constructing type systems like this. So I've read a lot of their blog posts, and that's why I was able to write all of this AST type stuff relatively easily. Whether it works now, of course, is another question, but, you know, okay. So we replace all split with that. Okay, and we're going to do this as well. All right, so that should handle that. So now we have a bunch of tokens. So we need to build up what our expression is. And then at the end of this, so homework is going to be a list of homework is going to be a list of sequences. All right. I guess technically it could be a list of expressions, but I'm not super fussed about that. You know what? In fact, let's just make it more generic. It's fine. Okay. So line is a new sequence. At the end of this, we're going to append line to homework. By the way, thank you, Eric. This is so much fun. This is much more computer sciencey, and I'm glad that you put more computer science in this, because yeah. Okay. So we'll write it this way for clarity. And each line has the ability to be evaluate. All right, so now we have that. So now we can have one of these. We can have one of these. We can have one of these. Or we can have one of these. And the default case is that this is just a straight numerical value. All right, I think that makes sense. All right. So in that case, this is pretty simple. We are always, by definition, going to be inside of a sequence. So by definition, the current expression is going to be a pointer to my sequence, to the overall line. So if we're in here, the current expression has its operands we're going to append a new number whose content is n. Okay. If it's a plus, then current expression operands, no, operators. Let's change, I don't like this. Oops, shit, I accidentally deleted that, that's fine. There, that's more readable. Plus, oh, add and mul, okay. All right, and in this case, oh, I see. So we need to keep the stack as well, so that we can always pop up. We need to be able to pop. All right. How do I handle pushing and popping in Golang? Well, one way of doing this would be keeping a reference to your parent, but I don't really like that. Yeah, I guess I could do slice tricks. All right, let's fine. Screw it. Let's do slice tricks. All right, so all right, so we're going to do it this way. I do not enjoy this greatly, but it's what I'm going to do. You know what? There's a shorthand to this that will make my life easier, maybe? Yeah. Okay. Alright. Okay. Alright, so that should work. Alright. Alright, I think that works. Will that work? I feel like this has got to work. Let's see what the syntax complaints are. Okay, so I've got a brace issue going on somewhere. Oops. Where do I have a brace issue? Oh, please. Really? Is that what lays me low? Is a brace issue? Expected declaration. This is a valid declaration. Do my braces line up? So, oh, I see the problem. Right, because Golang does this thing, so that's missing there. Okay, that makes more sense. So let's test it. All right, I've got a couple of errors. We'll just do this up here real fast. Okay. Getting towards the bottom of this, line 64, for I, comma s in range split. Oh, but we don't actually use I, that's fine. Okay. Failed to parse token 4. Why did 4? Oh, because I'm parsing s, whereas this should actually be token. The contents are indented by Go format, but if you have an incorrect syntax, then Go format won't run. It'll complain that you have invalid syntax. Parenthesis 7. Oh, I see. Really? I roll to disbelieve. Okay, so if every paren always doesn't have a space after it, okay, so that's easier. So we're just going to put that, and then close bracket between becomes close bracket like that. Okay. Okay, that's better. So we're now failing line 31. Why do I have an empty sequence? Sequence should never be constructed empty. So if sequence is constructed empty, I know I have a problem. So where was this called? This was called from inside of line 94. Line. There's another problem here. which is right here. I have a bug. And here we have another problem. Yeah, so a peak dot operands gets a new Okay, that seems straightforward. I'm pretty confident in this. That's correct. 1 gold star closer. Okay, advanced math. Addition is evaluated before multiplication now. Okay, we can work with that. So now, for each expression, when we're evaluating it, okay. So now we're going to add a flag for part B logic. So the only thing that I need to change is the precedence rule here. So we need to evaluate all of the pluses first, and then after that we evaluate all of the multipliers. Okay. So if not part B, then this is always true. Actually, no. All of this needs to be... What happens is the first value is a plus. That's still fine. That's fine. Okay. All right. So we evaluate all the pluses, and then after that we evaluate all the multiples. All right, how do we do this? So what I want to functionally do is I want to walk through replacing each time until I get to the end. Okay. I understand this. So what we have here is we can mutate the sequence in place, I think. So I starts as this was originally here. That's why I'm confused. Okay. we're going to shift everything over. How do I do this? I need to... I'm kind of making this trade-off doing this here rather than the parser, but I really don't want to monkey with the parser. All right, how do we handle this? Let's see. Hey, Epsilon. All right. Yeah. I'm wondering whether it is in fact better to handle this in the parser. Because if I handle it inside of the parser, the way that I would do this is as soon as I see a star, I would cordon off the expression and I would make a new expression. Yeah, as soon as I see a star, I would cordon the expression off, which should work. You know what? I'm just going to roll with this. Yeah, there are definitely easier ways to do this, but I'm doing this in the clean way rather than in the most beautiful way. Okay. So let's do it this way. At the end of this, what I should be able to do is I should be able to call should be able to do this. Okay, this should work. So now I just need to deal with all of the adds. Okay. Yeah, I think that's correct. So. How do I do this? I need to do some string slicing. Let's see. So append can put more than one slice together. How does that work? Oh, two slices can be stuck together. Okay. All right. I think that this is the fancy slice method I need? So if I see an add, I need to take the value at that position and the previous value and squish them together. Is that correct? Yeah, that's correct. All right, so yeah, that makes sense to me. And then we need to okay, that should work. And then okay. I think something like this should work. I think that does the appropriate amount of squishing. And we now have moved back a step. No, I stays the same, and we continue in order to progress our parsing. Okay, let's try that. I don't love this code, but we're going to run it. 950, what's wrong here? Oh, that needs a paren after it. Oh, grumble, grumble, really? Functions can only be compared to nil. Fine. We'll do it that way. All right. Getting closer. This is going to be just going to be a number. What? Oh, is that better? Let's do that so I can have a better look at it and you all can have a better look at it. Okay. So that's obviously bad. So I broke it. How did I break it? Oh, I broke it this way. Okay, that yields still the previous answer, so we're good. So we didn't break it. So now we run part B is true. Index out of range. Line 47. Oh. We always start evaluating from I equals 1. Yeah, that's going to be correct. And okay, slice bounds out of range, line 51. Oh, I see. If this is the last entry, then there may be more. Otherwise, I think I needed this. Just hope that's correct. Oh, the other thing is, yep, okay. All right, getting there. Oh. All right, that seems plausible enough. Let's just plug it in. That's correct. Fancy that. Okay, I got my code working. So let's review what we did, since that may have seemed like magic to a bunch of people. So what we did here was, oh, we should look at the advent calendar. Oh, we have landed at the island, having helped our math student with their maths problems. Cool. So we defined a grammar, which has the idea of an expression that has the idea of a number being a kind of expression, and having a sequence, aka a list of things that fall within parentheses that can be evaluated. And specifically, a sequence has a list of numbers to operate on, and has a number of operators of operations that need to be performed in sequence. So the evaluate function, if we're in part A, just goes left to right and evaluates the pluses and stars together. But if we are on part B, instead what we need to do is we need to coalesce all the adds first. And then after that, having done that transform, we can go ahead and process all the evaluates together. Or we can multiply all the remaining numbers together, knowing that everything that's left is a star. This is not the traditional way to do it. The traditional way is to modify the parser to take into account order of operations. But given that I am not using Yak or any kind of a thing that supports doing parser generation, I chose to do it in here instead. it's a kind of it's a personal choice which one you do. And if this were a real programming language, I would actually have the parser parse as part of the parser parse out which expressions go together. So basically, you would have a multiplication would be a higher order of would come later in the precedence than the addition, and therefore you would construct all the additions together, and then you would have a expression consisting only of additions but not multiplications that could be multiplied together. Okay. So once you have that, then we've got the operators that are just add and multiply, and then we do this to make our parsing easier by converting every parenthesis into a parenthesis space and every close parenthesis, etc. That way, we can just tokenize based off of everything is space separated. And then in the case that we are creating a new expression, we need to add it to the list of operands of our parent. And then we set our current expression to the child expression. When we're closing off, we're just declaring that expression done. So the current expression pops up a level, and we can continue adding more things to the end of our parent as a peer. And then add, multiply, and so forth. This does not catch the case of an improper grammar. This will not check, for instance, that you don't have 2 stars in a row or whatever. So a regular parser would defend against this in depth, but here we are not doing that because I'm just saying, you know what, I trust Eric gave us OK input. And otherwise, if it's none of those things, it must be a number. So we parse it as a number, and we hook it onto the operands. And then after that, we just go ahead and run it. So that's really it. It's a pretty, it's a pretty straightforward problem. I'm pretty happy with the solution. So let's go ahead and check it in. And you can go look at it on GitHub. So this will be at github.com/thosethegray/advent of code. Awesome. Well, thank you all for coming to watch me solve, and I look forward to seeing you again tomorrow night. Let's go ahead and turn the stream over now to someone else. So let's go ahead and do a raid. How about we raid Vincent? Let's do that. And if you're watching this on YouTube, remember to like, subscribe, and comment. Thanks. Be safe out there. See you tomorrow.